Hi everybody. Today's lesson is beginning the last part of the standard, which is worth 6 credits, the electricity standard. This was done in 2 parts. So we did one part on DC and static electricity. We finished that, and now this is the last little bit of that's required for your external examination, and this is called electromagnetism. I have put the PDF version of this on Google Classroom, so hopefully you should be able to find your way through it when we are back in class. These booklets already printed and ready for you. Now today's lesson, I'm just going to go through an introduction to electromagnetism. So first of all, what is electromagnetism? What does this whole word mean? So it's actually to study the relationship between an electric current and a magnetic field. Now that brings us to the word magnetic field. So what is a magnetic field? It's the area around a magnet or any other magnetic substance where another magnet or another magnetic material will feel a force. So the word force and fields go together. So when we talk about field, you also need to think of there's a force involved with that field. Okay, so where do we find magnetic fields? I'm going to talk about 3 places you could find a magnetic field. One is, as the name suggests, you would have a magnetic field around a magnet. There are magnets that come in all sorts of shapes, but I'm just going to draw an ordinary bar magnet. And all magnets, the ends of the magnets are called the poles of the magnet. Now one end is called the North Pole and the other is the South Pole. Now you wondered why they're called North Pole and South Pole? Why are they not just called left and right, or P and Q, or X and Y? The reason is, if you suspend a magnet so that it is free to turn about in whatever direction it wants to, it will eventually come to rest pointing in the north-south direction. That's why we have compasses. Compasses have a little bit of metal which is actually a magnet, and that always points to the north. Okay, and the first people to make use of these magnetic compasses were the Chinese. They used it in navigation, so they got thin slithers of the actual magnet. It was called lodestone years and years ago, and they tried, I think, floating it on water, and that's how, and they saw that it always pointed in the north-south direction. So the end of the magnet that points to the north is called the North Pole, and the end of the magnet that points to the south is called the South Pole. Now around this magnet you have a magnetic field, and we always represent a magnetic field by drawing field lines. Now the field lines around a bar magnet look like this. Now field lines never cross each other, but they actually kind of end and begin at the magnet, and these field lines have got a direction. So the direction of the field lines is the direction in which a north pole would move, and a north pole would always move towards the south pole, because unlike poles attract and like poles repel. Okay? If on the other hand you had 2 magnets and you had similar poles facing each other, or you could have opposite poles facing each other, then the shapes are a bit different. So let's say north, south, south, north. So you got similar poles facing each other, north, south, north, south. You got opposite poles facing each other. So you just need to know what the shape of the magnetic field in this sort of situation would look like. So there's going to be repulsion between these two. They don't really like. South doesn't like the south. So you get the field lines. And this one, you've got straight lines to show there's a uniform magnetic field between 2 opposite poles of a magnet. Let's draw one more set of lines. Here we go. And then the arrows, so I've got to draw the arrows coming out of the north, into the south, out of the north,